Hello everybody, welcome back to my YouTube channel. So in this video, I'm going to show you how to clean data like a pro. Are you tired of dealing with messy data sets, missing values, duplicate records, incorrect data types? Well, you're not alone. In this video, I'm going to show you how to clean data like a pro using Python. Wait, but before we dive in, why is data cleaning so important? Do you know that 99% of data scientists spend most of their time cleaning data at work? Without a thorough data cleaning, your analysis and model will be totally inaccurate. So, I'm going to teach you how to fix this right now. Now, I know that you're so excited to get into the project. Well, I'm excited too. But before we go ahead, I want to tell you that this tutorial is actually divided into two phases, but is actually in one video. Now, the first phase will be where we'll be using a beautiful presentation to walk you through what data cleaning is, why data cleaning is important, and also show you most mistakes data scientists and data analysts do when performing their data cleaning. While the second phase will be taking you through a thorough analysis on data cleaning using Python. In the second phase of this tutorial, which is the practical phase, we are going to be making use of a very messy data and we are going to be performing an in-depth data cleaning on this data. Are you excited? Because I am excited. Now enough of the talking, let's just get started.
So let's go ahead and look at what is data cleaning. Data cleaning is a process of making a data set clean, error-free, and suitable for analysis or model building. When we are cleaning a data set, we are ensuring that the data is totally clean and organized to perform analysis. Now, when we are talking about data cleaning, we are actually trying to make the data set clean and error-free for data analysis or for model building. Now, this includes looking for duplicates and eliminating duplicated values, looking for inappropriate entries or errors during entry, and it also involves handling our outliers and ensuring that we have no missing values in our data set. Now let's take a look at these two images. Now in this image, you can see this is actually showing a messed up or a dirty data set. Now when you take a look at this data set, you can see that it is not properly cleaned and it is not properly organized. Now this is actually the name. Okay, this is the name. Now this is also the address, then this is the age, and this is the gender. But when you take a look at this, you will see that this data is not appropriately organized. It is not cleaned up because all the variables are actually missing up together. Now, one thing you need to understand about data is that it makes it difficult to understand. When the data is not cleaned, when it's not organized, it makes understanding the data very difficult and it messes up our analysis and our model building. Now, when we go to this clean data, as we can see that in this situation, the data has been properly cleaned. Like now we can categorically tell each columns of the data and we can also understand what each column of the data is actually talking about. As you can see here, we have the name, the address, the age, and gender. So these two images actually represent a dated or a messed up data from a clean data. Why is data cleaning important? Improves data accuracy. Cleaning removes errors, duplicates, and inconsistencies, ensuring more reliable insights and predictions. Now, when our data is thoroughly cleaned, when we remove our errors, our duplicates, and inconsistencies during entry of data, it makes the data reliable. And it ensures that any insights we are actually getting or predictions we are actually getting from this data is accurate and they are reliable. Enhances decision making. Clean data leads to better analysis, helping businesses and organizations make informed data-driven decisions. We draw insights from our data, and when the data contains errors or is actually inconsistent, it actually affects the insights we are going to draw from this data. Now, let's say, for example, we are actually trying to make an analysis for a financial company, and in a situation for a financial company, and for instance, let's say we have total sales, and total sale was represented as minus $30,000 when it should actually be represented as $30,000. Now, this is why it is accurate for us to clean our data and perform data validation, because If you're working with this type of data, you will see that the insights we are going to draw from this data will be inaccurate, boosts model performance. In machine learning, high quality data, clean data improves model accuracy and reduces bias. Now, in this situation, when we are actually building our machine learning model with an inaccurate data, it reduces model accuracy and leads to high bias, increases efficiency. Well-structured and clean data saves time in processing and analysis, preventing costly mistakes and rework. The impact of dirty data on data analysis, inaccurate insights. Errors, duplicates, and inconsistencies in data can distort analysis results, leading to misleading conclusions. Poor decision making. Business strategies and operational decisions based on inaccurate data may result in financial losses and inefficiencies. Reduce model performance. In machine learning, dirty data increases bias and reduces model accuracy, leading to unreliable predictions. Common data cleaning errors and how to avoid them. Missing data. Error. Blank or null values in datasets can lead to biased analysis. How do we handle this issue? We can make use of techniques like imputation, imputing the missing values with mean, median, or mode, or remove the records if appropriate. Duplicated data, error. Repeated entries can skew analysis and lead to inaccurate insights. Solution. Identify and remove duplicates using unique identifiers or data validation checks. Inaccurate data types. Error. Mixing numeric and categorical data types can cause processing errors. Solution. Ensure proper data types, e.g., converting string numbers to integers or floats. Now, in this situation, when performing your analysis, some data type can be misinterpreted. For example, when we have a column that is total cells from, as the name implies, should actually be an integer or a float. But in some situations, you'll be seeing it as a string, which is inappropriate. Now, it is your responsibility as a data analyst or data scientist to actually convert this data back to its appropriate data type. Cleaning data manually and automatedly using Python. Manual data cleaning in Python. Manual cleaning involves using Python libraries like Pandas to identify and correct errors step by step. Now let's look at this example here that shows the process of cleaning data with Python manually. Steps in cleaning a data set. Now we have various steps in cleaning a data set. Now this flow chart here shows the steps involved in cleaning a data set. Now as you can see, the first step here is importing the data. So once you import data, then you merge data sets. Let's say, for example, we have different tables we are actually working on. If we have different tables we are actually working on, this is when we have to merge data sets. But in a situation where we are working with just a single table, there will be no need to actually merge our data sets. Now, the next thing we have to do is rebuild missing data. Now, this is actually where we rebuild our missing data, like looking for missing data and filling them appropriately. Now, the next is standardizing the data. Then we move to normalization. Then we move to deduplicates. Now, this simply means handling your duplicated values. Then you verify and enrich. Now, in this situation, you're trying to verify all the changes you have actually made, and you can actually decide to make more changes to it, okay, if necessary. Now, the next thing is to export your data. Okay, so once you're done cleaning your data and everything, then you can decide to export your data in case you want to use it for building a dashboard.
So the first thing we have to do here is we just have to go ahead and open our Jupyter notebook, which is the environment we're going to be working with for this data cleaning tutorial. So the next thing we have to do is we go ahead and rename this. So let's go ahead and call this data cleaning. So the next thing we have to do is let's go ahead and import necessary libraries. So the libraries we'll be working with is, let's go ahead and import pandas as PD. Pandas as PD. Then let's import NumPy as MP. Then let's go ahead and import visualization library. First thing we have to import is, let's import missingno as MSNO. Then let's import seaborn as SNS. And let's import matplotlib. Matplotlib imports pyplot as PLT. Then let's go ahead and import warnings. So let's import warnings. Then let's say warnings dot filter warning. Ignore that. Ignore all warnings. So let's go ahead and run this. So let's wait for this to run. We have an error here, no model named warning. Yeah, I think we have to do an S warnings. So we have successfully imported this. So the next thing we have to do is, let's go ahead and import our data set. Our data sets. So let's turn this to markdown, then let's run this. So to import our data sets, let's call it df, then pd.read, the CSV file. So we use CSV. Then let's go ahead and copy path. So let's just copy this, copy paths. So let's go ahead and paste our path here. So let's go ahead and put our read. So let's go ahead and run this. So we have successfully imported our data set. So let's do some investigations before we go into our data cleaning. So the first thing I want us to look at here, let's look at how many columns and rows we have. So as you can see, this is quite a large data set. So we have about 148,654 rows with 13 columns. So let's go ahead and look for the first 5 rows of our data sets. So this is the first 5 rows of our data sets. Okay. Then let's go ahead and look for the first last rows. Okay, so this is the first last row. So as you can see here, I'm already noticing some issues here with order pay and total pay. Okay, so we are going to check that later. Let's just go ahead and move ahead. So let's look for the statistical information of our data sets. Describe. Let's go ahead and run this. So this will not be appearing this way. We have to put this. So this is a method. So okay, so this is our statistical information. There we can see our mean, our standard deviation. There we can see our media and maximum and minimum values. So the next thing we have to do, let's just go ahead and do our data cleaning. Let's go ahead and call our df.head again to see what we want to do. Okay. Now let's go ahead and continue with our data cleaning. Now I want us to look at this properly. When you look at this properly now, you'll see that we have ID here, okay, which is the same thing this is actually doing here. So we don't need this ID for anything. So what we need to do is we have to just go ahead and drop this ID. But before we go ahead and drop this ID, let's just go ahead and get more information on our data set. So let's do the update info. Now I want us to clearly look at this data set thoroughly. Okay. Now let's study this data set to actually see if we have any errors in the data type and other stuff. Now, like I mentioned, we are going to be dropping this ID, but it's not necessary. It's just like the index here. So it's just like this ID and the index are doing the same thing. So we don't actually need ID for our analysis. That's if we are going to be performing an analysis. But in this situation, we are not performing any analysis. We are just doing a thorough cleaning on these data sets. So we are going to drop this. Okay. Then let's look at employee name. Okay, objects. The employee name is object, which is categorical data. Okay, which is correct. Now let's look at our job title, which is this column here. So our job title is also an object, which is correct. Then let's look at our base pay. Our base pay is an object. So this is our base pay. Our base pay should be a float, not an object. So there's no way we can actually say base pay is an object. So this is incorrect. So we will have to change the base pay, okay, to float. Now, the same thing goes for overtime, other pay, benefits, and total pay. And also, I think the same thing has to go for total pay by benefits, okay, which is this. Now, the next thing we have is the year. Year here is giving us an integer, which is this. Okay, year is giving us an integer, so year is incorrect. So any dates column has to be in date time, not integer or float or string. Now, the next thing we need to look for is notes. Now, when you look at this notes, it's giving us clue, okay? But there's something we need to understand here. This note is having zero variables in the rows, okay? This simply means that there are no variables in the rows at all. But let's just not go ahead and conclude. Let's go ahead and confirm this, all right? Now, to confirm this, let's do df note. Let's just check the unique count. Now let's go ahead and run this. So when you run this, you see that it's giving us any n, okay? Which simply means that all the columns, which simply means that all the rows in the column node is actually empty, okay? So it's actually empty. That means all the rows in the columns is none, is missing, okay? So that means we have to also drop this node, okay? Now let's go ahead and look at agency. It's giving us that agency is object, which is correct, categorical data. Now let's go ahead and look at status. Okay, it's giving us that status is an object. And when you look here, there's no way we can confirm if status is an object. So we need to do value count or check the unique variables in status. Now let's go ahead and do status here. Let's do value underscore count. No, no, no attribute called value count. Okay, I think S has to be here. Go ahead and run this. Okay, so as you can see, we only have full-time and part-time. Okay, so this means that it is correct. Status is object, so which means that it is correct. Okay, because ft and t are categorical data. Okay, that's string. Now the next thing I want us to actually look here is this. Okay, now when we checked our data type, okay, the shape of our data, we said we had a total of 148,654 rows, okay, and 13 columns, okay. So now when you look at here, any column that is not up to 148,654 it simply means that we have missing values in them. Okay, but we are still going to confirm that. But now when you look at this thoroughly, you can see that we have missing values here, we have missing values here. This one is, we are going to be dropping this, so we also have missing values here. Okay, so when you look at this properly, it simply means that we have missing values in like two columns, okay, which is this and this. Okay, aside from this one that is empty that we are going to drop. Okay, now as you can see, we actually have to change most of the columns here to the appropriate data type, okay, because they are not in their appropriate data type. Then we also have to drop this, and we also have to drop this. Okay, now let's go ahead and drop columns. Let's just drop id and not columns. Need to add a hash here, comment out. Now to do that, let's say df is equals to df. Okay, okay, so df is equals to df dot drop. Okay, I think this should be, let's try it this way. So df is equals to df, let's call this id. Okay, let's say dot drop. Okay, then this should be columns equals to, columns should be equals to id. Okay, then this as this equals to 1. So let's go ahead and check if this works. Now let's go ahead and check if this has been reflected. Let's do df.head. Let's run this. Okay, df.head. Okay, I think this code we actually use is quite long. Okay, let's go ahead and see how we can fix that. I think we just have to remove this. Then let's say columns equals to id. Okay, columns equals to id. This should come here. And as this is equal to 1, so let's go ahead and run this. So now let's go ahead and run this. So we just have to go ahead and run all cells and say, okay. Now as you can see, we have successfully eliminated the id column. Okay. Now we just have to go ahead and copy this and paste it to also eliminate the node. Okay. Now we just have to correct this and say, or let's just complete this code instead of doing it differently. So let's say df.drop. Okay, then we say columns equals to, let's call this our not, then axis equals to 1, equals to 1. Okay, now let's go ahead and run all cells again. Okay, so when we run all cells now, as you can see, we are having an error. id not found in. Okay, so this is, you just have to go ahead and delete this. Okay, id has already been dropped here, so there was no need for that column again. So we have successfully dropped id and no. Okay, now let's just go ahead and check. Let's go ahead and do df.info again, so we know what's next we are working on. So let's do df.info. So when we do that, let's go ahead and run this now. Okay, so as you can see, the next thing we have to do is changing our data type, okay, to the appropriate data type. Okay, now I want us to start with base pay. Okay, now to change our data type, we make use of as type. Okay, so let's say changing base pay from objects to float. Okay, now let's go ahead and say, to do that, let's say df is equals to df let's call this base pay. So let dot as type. So this should be floats. Okay, so let's go ahead and run this. So could not convert string to float, not provided. Okay, so this simply means that in the base P, okay, there are rules that are actually called not provided. Okay, now the thing we have to do is, let's just go ahead and create another column here. Okay, now the error we got was could not convert string to float, not provided. Okay, now let's just go ahead and do the unique terms for this to know what this is all about. So let's say df, then let's say base pay, then let's say dot unique. So let's go ahead and check. Now, as you can see in the rules, okay, of base pay, there are rules, okay, that are filled with not provided. Okay, so this simply means that some employees did not actually fill their base pay. Okay, so the employees that did not provide their base pay, maybe the data entry specialist just choose not provided for it. Okay, now there is no way we can convert base pay, okay, from objects, okay, to float when we actually have rows that are string. Okay, so because some rows are categorical data, there is no way we can actually convert base P, the column base P, to a float when some rows are categorical data. So the first thing we have to do, we actually have to fill this not provided with 0. Okay, so let's go ahead and do that. So let's say df, okay, is equals to df. Let's call this base pay. Then to do that, let's make use of dot replace. Okay, so this should be not provided. So we are replacing not provided with 0. So replace it with 0. So this code, what this code does is, for any row that was filled with not provided, it will replace it with 0. Okay, so we can actually go ahead and convert it to float. Okay, now let's go ahead and run this. Let's go ahead and run this again. Say base pay as type float base pay. Okay, let's know where the error is coming from. So let's go ahead and confirm this. Now let's do df base pay. Okay, base pay dot info. Now we're going to see if we have successfully changed base pay to float. Now it's showing base pay. So let's go ahead and look at what we did here. This should be df base pay. Df base pay. The dot as type float. Let's go ahead and run all again and see. Now, when you go ahead and check this, now you see that we have successfully changed this. Okay, we have successfully changed base pay to float. Okay, so as you can see now, it's showing float instead of objects. So let's just go ahead and print head of our data frame. Let's run this. Okay, base pay. Okay, now let's go ahead and check info, the entire data frame. Let's see what next we are working on. As you can see, base pay is now showing float. Okay, base pay is now showing float. Okay, now we have to do the same thing for overtime. Okay, but before changing the data type of overtime to float, okay, we actually have to ensure that there are no categorical rules, okay, in our column. Now to do that, let's just say overtime, and we just say df dot, no, df overtime dot unique and showing overtime. Then that should be overtime overtime pay. So on this again. Now this is showing us we also have not provided. Okay, we also have not provided here. So we just have to go ahead and also replace this not provided with zero. Okay, but instead of to go ahead to be doing it one after the other, as you can see, we still have to work on order pay, base pay, total pay, and total pay benefits. We can just write this code at once. Okay, now what we have to do here is, let's say, replacing over time. Let's just go ahead and copy this code here. Okay, replacing not provided with zero across why am I missing the spelling of across? I don't know if that's correct. Across all other columns. So let's just go ahead and paste it. Now let's change this to overtime pay. Overtime pay. Okay. Let's also change this to overtime pay. Okay. Then we can go ahead and change the data type. Okay, so all we have to do is let's copy this code here and let's just paste it here. Let's say changing data type for overtime pay. And let's paste this here. So all we just have to do is let's call this overtime pay. And let's call this overtime pay. Now the next thing we have to do is let's do the same for order pay. Let's do the same for order pay. So to do the same for order P, we just have to do replacing not provided with zero for order P. So to do that, we just say df, then we say order P. Okay, then this should be equals to df order P. Okay, then this should be dot replace. So we are replacing it with zero. So we say order P. So we say not provided. Okay, then zero. Okay, then we can go ahead and change data type to float. Change data type for order pay to float. Okay, now to do that, let's go ahead and do df over time df over time, and that is df order pay, please. Df order pay equals to df order pay dot as type. Order pay, so dot as type. Then this should be float. Okay. Now we have to go ahead and do the same for order pay benefits. Okay. Replacing not provided in benefit review. So the same thing, we just have to go here and copy this code to make this a bit faster. Okay. Now let's go ahead and say, let's call this benefit. Okay. Then let's call this benefit. Now, okay. The next thing we have to do is changing the data type to float too. Then changing, okay, change data type for benefit. Okay. So just use this code, copy and paste, then we just change it to benefits. Then let's change it to benefits too. Benefits. Okay. Then float. Then we just have to go ahead and do the same thing for this. Now let's change. So to do the same for this, we just have to replace 2 with 0. Now let's check what we are working on. We are working on total pay. Okay. So let's do total pay. Total pay. Okay. So we have to just eliminate this and write total here. Then we eliminate this and write total. Okay. Total pay. Okay. Then the next thing we have to do is changing data type. We have to change the data type for this too. Now to do that, let's go ahead and copy this code here. And let's paste it here. And let's call this total pay. Okay. Then let's also call this total pay. Okay. So the next one we have to do is for total benefits. Okay. So let's just go ahead and copy this here. Okay. So let's say replacing not provided with 0 in total pay benefits. Total pay benefits. Okay. So let's go ahead and paste this code. And let's call this total pay benefits. Okay. Now let's go ahead and call this total pay benefit. Like I say, total pay benefits. Total pay benefits. Okay, this makes sense. Now let's go ahead and change data type. Now to do that, we just have to copy this. Let's paste this here and let's just copy this from here and paste it here. Okay. So we'll paste this here too. Okay. Now let's go ahead and run this to see if everything we wrote was correct. Okay, so this simply means that we have successfully changed all the data type, okay, to their appropriate data type. All right. Now we still have to work on year. Okay, we have to change it to date time. But before that, let's go ahead and confirm what we have done. Let's say df.info, df.info. Okay, so this simply means that we have successfully changed all this to float. Okay, so now the next thing we have to work on is year. Okay, but before we do that, let's go ahead and look for the unique values in year. So let's do df unique values in year. So we do df sorry, df year dot unique. Now let's go ahead and run this. Okay, so we have 4 different years: 2, 1, 2, 12, 2, 11, 2, 12, 2, 13, 2, 14. Now to change it to appropriate data type, we use pd.datetype, date time, change year to date time. Now to do this, let's say df year. This should be equals to pd dot to underscore date time. Okay, so this should be df year. Now let's go ahead and run this. Now let's go ahead and verify if it worked. So let's check for results. To do that, let's say dfa.info. .info. Now let's go ahead and run this. Now, as you can see, data type, we have successfully changed it to date time. Okay. Now let's move ahead to know the next thing we have to do. All right. So now we have successfully handled changing our data types, okay, into their appropriate data types, okay. Now the next thing we have to do is let's go ahead and handle missing values. So let's say df.info, okay. Now, as you can see, like we mentioned earlier, that we have a lot of missing values in some of the columns. Okay. Now, there are various ways you can actually handle missing values. You can actually handle missing values by dropping them, or you can handle them by filling them with the mean, median, or mode, or you can equally handle them using the backfill method or forward fill method. Now, there is a method we use for filling missing values, and it is called the dot final. Now, let's go ahead and check for missing values in our data frame. Checking for missing values. Now, let's go ahead and say df.isNot.sum. IsNot.sum. Now, let's go ahead and run this. Now, as you can see, we actually have missing values in 1, 2, 3 of the columns. Okay, we have missing value for base pay, we have missing value for benefits, then we have missing value for startup. Okay, now for the base pay, there is no way we can say we are going to drop the base pay. Okay, now there are two ways we can do this. Okay, since the base pay is not provided by the employee, all right, we can decide to fill this base pay with 0. Okay, so instead of us to just go ahead and fill it with amounts, okay, that we don't know or that we are not sure of, we can decide to just go ahead and fill the base pay that we are not provided with 0. Additionally, we can decide to go ahead and handle the base pay by filling it with the median. Okay, but for the course of this particular tutorial, I'm going to be filling the base pay with 0. Okay, now let's say handling missing values for base pay. Now I can say df base pay equals to df base pay dot spinner. So value should be equals to 0, equals to equals to 0. Now let's see if that works. Let's go ahead and run this. Now let's go ahead and check results. Now to check the results, we do df base pay dot isNo dot sum base pay dot isNo dot sum. Now let's go ahead and run this. As we can see, it came out as 0, which simply means that we have successfully handled the missing value for base pay. Okay. Now let's go ahead and handle the missing value for benefit. Okay. Now to handle the missing value for benefit, okay, that means we can decide to drop it. All right. But because of the missing values are quite large, okay, so we cannot go ahead and drop it. Okay. So we can actually decide to fill the missing value with for base pay with 0, okay, or we can decide to fill it using FP method, or we can also decide to fill it using the mean. Okay, that means we calculate the mean base pay and fill the mean base pay with the and fill the missing values we have in the base pay columns with the mean base pay, okay, with the benefits mean. Okay, I'm sorry, I'm making a lot of confusion when explaining that. Now, let me take that again. What I'm saying is because of the data that are missing in the benefits column is quite much, okay? It's not advisable to go ahead and drop them. Now, we can decide to fill it with 0, or we can decide to fill it with the mean, the mode, or the media, or using the back P method or the forward P method. But now, for the course of this tutorial, I want us to calculate the mean of the benefit column, okay, then use the mean of the benefit to actually fill the missing columns, okay. I hope that makes more sense. So let's say handling missing values for benefits column, so to do that, firstly we have to go ahead and calculate the mean. So let's say mean underscore benefits, this should be equals to df benefits dot mean. Okay. Now let's go ahead and fill the base pay, the missing values with the mean, filling missing values with mean. So this will be df base benefits is equals to df is equals to df benefits dot fina or fina. Now value equals to mean benefits. Okay. Now let's go ahead and run this. Okay, so it seems this works. All right. So now let's check for the result. Check results. Check results. It's working. So let's check for the results. Now to check for the results, all we have to do is df benefits, okay, dot isNo dot sum. Now let's check that. So as you can see, we have successfully filled the benefits, okay? The missing values in benefits with the mean, all right? Now, the next thing we have to work on is the status. As you can see, we have a lot of missing values in the status. But first, let's check for unique values in status. Unique values in status to know what we are working with. Now, to do that, we say df status dot unique dot unique. Now, let's go ahead and run this. Okay, so as you can see, we have the missing values which we are trying to handle. Then we also have part-time employee and full-time employee. Okay, now there are several ways we can actually handle this. Okay, we can decide to calculate the base mean, okay, the base pay mean, okay, and fill and write a code, okay, that we fill once. Sorry, let me take that again. Now we can decide to write a code, okay, that would fill. We can decide to calculate the base pay mean, okay. Now when we calculate the base pay mean, we can write a code that if the base pay for any missing value in the status is equals to the base pay mean, it will fill it with full-time staff. But if it is not equals to the base pay mean or it is below the base pay mean, then we fill it as part-time staff. All right. But for the course of this tutorial, we are just going to handle this status missing values with forward fill. Okay. Now to do that, what we have to do is, let's say, handling missing value for status, right? So we say we are going to handle this using ffill, sorry, using backfill. Now to do this, we say df status is equals to df status dot final value value. I'm trying to remember that should be method, right? Method equals to backfill, bfill, right? Now let's try that. Now let's go ahead and check the result. Now to check results, we say df status dot is not dot sum. Now let's go ahead and run this. As you can see, we have successfully handled all our missing values. Okay. Now, the next thing we have to do is let's go ahead and check for and handle outliers. Check for and handle outliers. So let's go ahead and turn this to a markdown. Now, to check for and handle our outliers, the first thing we have to do is we have to extract our numerical and categorical columns. Now, why are we extracting our numerical and categorical columns? You know, when we are talking about outliers, outliers only affect our numerical columns, okay? So there's no way we can use our original data frame that combines that is a combination of our numerical and categorical columns. It's not going to work. So we have to extract our categorical column and also extract our numerical columns. Now let's say extracting numerical categorical columns first. Categorical columns. Now let's declare a variable that we call it cat underscore code. Okay. Now this will be like the variable that will be housing our categorical columns. Okay. Now this should be equals to dl df dot select. I just hope I'm getting that underscore d types. Yes, I think this is it. Underscore d types. Okay, then I think it should be include equals to objects. Now let's go ahead and run this and see. Okay, that data type object's not understood. So there's something wrong with our code. Now let's go ahead and figure it out. Okay, this should be a small letter. Okay. Now let's check for results. Now to do that, let's just call cat underscore code. Now as you can see, it has actually brought back our numerical, our categorical data. Okay. Now we see our categorical columns, which are the employee name, job title, agency, and status. Now I want us to reconfirm that we have no missing values for these columns. Now let's also cat call dot is not dot is not dot sum. Okay. Checking. Let's say we're checking for missing values in our categorical data frame. Now, as you can see that there are no missing values, okay? So which simply means that we perfectly handle the missing value for status. Now, the next thing we have to do is let's go ahead and extract our numerical columns. Now, to do that, let's declare a variable and call it num underscore pose. This should be equals to df dot select underscore d types. Okay, then this should be equals to columns. Sorry, this should be equals to include equals to float ints. Okay, let's try that. Okay, now let's go ahead and check for result. Check for results. Now let's just call num underscore code. Num underscore code. Now let's run this. You can see we have successfully extracted our numerical column. Now, I want you to look at these columns very well. Now, when you look at these columns, you will see that under this order P, we have a negative value of 1618, 618.13. Likewise for the total pay and likewise for the total benefits. Okay. And this row actually belongs to an employee. Now, this particular data is actually a salary data, okay? The salaries for employees, okay? Salaries for employee in a particular region in the United States. Now, there is no way this data do not contain loan, okay? It doesn't take note of loan. It doesn't contain loan or maybe overdraft, okay, given to a customer, given to an employee, sorry. Now, there is no way an employee will have other pay as a negative value. And there is no way an employee will have total pay as a negative value. Likewise, for total pay benefits. Okay, so it's not possible. So I can assume that this particular negative sign here is not a negative sign, rather it is just a non-numerical column. Okay, it's just a non-numerical variable, a non-numerical attribute. Now what I'm going to do is I'm going to eliminate this. Okay, I'm going to treat it as a non-numerical variable. Okay, and eliminate it using absolute. All right. Now to do that, let's say eliminating. non-numerical variables in in order pay, benefit, order pay, total pay, and total pay benefit. Sorry. Now to do that, what we have to do is let's go ahead and say df order pay, okay, is equals to df order pay, okay, dot abs. So we can just do the same for, so we can just copy this and do the same for the rest. Now let's just say for order pay, then we can come here and say for, what's the next? Order pay, total pay, okay, for total pay, okay. Then the next one we can say for total pay benefits, total pay benefits, okay. Now we can just copy that. Now all we just have to do is let's copy this now and paste here, paste, paste. Then let's copy this total pay and paste here, paste, paste. Okay, now let's go ahead and run this and see. Okay, now let's go ahead and check for results. Check for results. Now to check for results, let's go ahead and say df, or let's just go ahead and say num underscore close dot tail. Okay, so it is actually still here. It is still here. The negative values are still here. All right. Okay. Now, why are the negative values still showing? All right. Now, we are actually trying to check for result with numpy. Okay. Why we actually worked on this using df. Okay. So, definitely is not going to work. It's not going to work. It's not going to work. Now, what we have to do is we just have to change this to num underscore pose, 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 num underscore pose. Okay. Now let's go ahead and run this again. Let's just go ahead and run all. Run this. Let's run this again. Now, as you can see, it has been eliminated. Okay. Now we just have the C with no non-numerical attributes. All right. Now we have successfully extracted our numerical and our categorical columns. Okay. Now we have to undo. We have to visualize our outliers. 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 Now we are going to visualize our outliers using box plot, okay, before we go ahead to handle the outliers. Now the first thing I want us to do is let's go ahead and create a box plot, okay. Now this box plot will help us show outliers. Now, I want to know if our data contain outliers before we go ahead to handle outliers. Now, to create that box plot, what we need to do is, the first thing we need to do is plt.figure. This is creating our figure size. This will be fixed size. So be fixed size equals to, let's say, let's use 12 by 6. Now, the next thing we have to do is let's go ahead and create the box plots, and we are going to do that using seaborn. So that should be sns.boxplots, box plots, okay? Then that should be value equals to num underscore cos, okay? Now, the next thing we have to do is let's go ahead and put our title, okay? plt.title, okay? And let's call this box plot to determine, to show outliers, okay? Now, the next thing we have to do is let's go ahead and do a little bit of aesthetics, okay? That should be rotation, should be 45, rotation equals to 45. Now, let's go ahead and run this. Okay, now I think this should be plt.show. I need to use plt.show to show this. But before then, we got an error. Okay, it was never closed, so we have to close this. Now let's go ahead and run this. Okay, so why is it not showing us what we need to see? That means that there must be something wrong with our code. Now let's go ahead and check it back. So plt.figure fixed size, okay, sns.boxplots value. Okay, this should be data, not value, but we are working with data. Equals to num underscore pole, boxplot, okay, rotation 45, plt.show. Let's try this again. Okay, think that worked. Now, when you look at this now, you'll see that we have outliers here. Okay, we have outliers here. Now, one thing is you need to be able to understand your data. Okay, you need to be able to understand your data very well. Okay, now when you're working with a company, there's some things you should try to understand. Are these really extreme values? Are they really outliers? Especially when you're looking at the total pay or total pay benefits. Okay, are they really outliers? Okay, or is it that some employee just got a lot of benefits, okay, for that month, or they actually did a great achievement, or they achieved something for the company that actually skyrocketed their total pay or their total benefits, okay? But however, since we don't have much detail on the data, we'll just go ahead and handle our outliers, okay? Sometimes, especially when you're working with sales data, okay, all you have to do is when you have outliers, when you're working with sales data and you have outliers like this and you don't really understand the data very well, okay, all you have to do is the outliers. Okay, you just have to cap the outliers because one, you can't determine if there are two outliers or if there are just significant changes in sales, okay, in the company. So all you just have to do is to visualize or you cap your outliers, all right? But in this situation, we are going to handle our outliers, okay? Now, there are various ways of handling your outliers. You can actually handle your outliers using the IQ arrow, or you can handle your outliers using the Z-score, or you can simply cap the outliers like I mentioned earlier. So in this case, we are going to handle our outliers using the IQ arrow, okay? So let's say handling outliers using IQ arrow, IQ arrow. So to do that, we are going to be making use of this code. Now, this code is quite simple, okay? If you have been seeing other of my videos, I've actually explained what IQR is and explained how, I've actually explained what IQR is and actually what it does, okay? That's how IQR helps us to handle our outliers, okay? Now we have successfully handled the outliers. Now let's just go ahead and check for results. To check for results, all we have to do is let's just copy this here. Then let's just paste this here. Now let's run this. So as you can see, we have successfully handled our outlier. So since we have handled our outliers, the next thing I want us to do is let's go ahead and transform this data. Okay. Now, after transforming this data, the next thing we have to do is plot our histogram. Okay. Now, for the course of this tutorial, we are not going to be using log transformation, okay, which is the one that most people actually make use of. But for the principles of this tutorial, we are going to be making use of the box course. So now this is the code we are going to be making it for that. Okay. Now let's just go ahead and run this. Now this gave us an error and it says start is not defined. Okay. Now this simply means that for us to actually use this code, we actually have to import, okay, a library. Okay. And that library is actually called start. Okay. It's from, we import it from the SciPy library. Now to do that, let's just go ahead and import that here. And to do that, we say from SciPy import star. Okay. Now let's go ahead and run this. Now let's go ahead and run all. Okay. Okay. So this has been successfully transformed. Now the next thing I want us to do here is let's go ahead and plot a histogram. To do that, we are going to be using this code. All right. Now let's just go ahead and run this. Okay. So this is it. All right. Now let's go through what we did firstly. Now, the first thing we did was importing the necessary libraries. Then we imported our data set. We did our data investigation where we looked at our shape of the data. Then we looked at the head of the data, the tail of the data. Then the next thing we did was statistical information on our data using df.describe. Then we entered into our data cleaning. We got more information on our data. Then we actually check the unique values in notes, okay, and we also check the unique values in status, okay. Then we dropped our id column because according to what we mentioned, is not necessary. All right. Now the next thing we did was we went ahead to check for the unique values in base pay, and we found out that we have not provided. Okay. Now we mentioned that for us to convert base pay from categorical column to numerical column, for us to convert it from object to float, we actually have to convert these rows that actually have not provided to zero, because not provided is a string. There's no way we will have a string in a column while we are trying to convert it to a numerical column. So it's not possible. So we had to fill the base pay with zero. Okay. So what we did was we filled the not provided with zero. All right. So we did the same for overtime and the rest of them. Then the next thing we did was we checked for the unique value in year. Then we converted year from we converted year from integer to the appropriate data type, which is date time. All right. Then the next thing we did was we checked for missing values, and we had missing values in base pay, we had missing values in benefits, we had missing values in status. The next thing we did was we started handling our missing values. So we handled the missing values in base pay using .fina. We filled it with zero. Then we handled the missing value for benefits, we filled it with the mean. Then we handled the missing value for status, we filled it with BP method. Then we checked for our outliers. Then we extracted our numerical columns and we extracted our categorical columns. All right. Now we confirm to check if there are missing values in our categorical columns after extracting the categorical columns, which there was none. Then here we extracted our numerical columns. Then over here we eliminated non-numerical variables, okay, that we found in order pay, total pay, and total benefit. Then here we just confirm to make sure that the non-numerical attributes have been eliminated. Then we plotted a box plot here to check our outliers, which we found out that we had outliers. Then here we actually handled our outliers using IQ arrow. Then we actually show, okay, we checked for results to show that our outliers has been handled. Then we actually applied box cost transformation. Okay, like I mentioned, instead of the bus cost transformation, we actually use the log. Instead of using the log transformation, we decided to use the bus cost transformation. They actually do the same thing. Then the next thing we did was we wrote a code that integrated and plotted a top plot, okay, histogram for all the numerical columns. All right. So this is it.